Okay, so let me just introduce matrices. Now, let's first start to talk about the order of a matrix, or how do we pronounce that? Or so, if we say we have an m by n matrix. If we say we have an m by n matrix, that just means like we have m rows, and then we have n columns to that matrix. We have m rows and n columns to that matrix. That's just how we pronounce a matrix. So if we have a 4 by 3 matrix, that means like we have a four rows and three columns if we have a 4 by 3 matrix. So how does a matrix work actually? So let's first start to see something. If we have matrix A, here we'll have an entry A1 1, and here we'll have an entry A2 1, an entry A3 1, and progressing like that. You can have multiple rows, m rows. But now the point is like going downwards, you only count the rows, so which is what this numbers here implies. And if we go to the right, that means we'll have A12, A13, and progressing like that. So when you go towards the right, you only change the values, the last values. Then that just tells you the columns of that matrix. So this just means row 1, column 2. This means that row 2, column 1. So it's just basically that simple, really. And now the last entry there on the bottom right, that will tell you your matrix. So this one will be a 3 by 3 matrix. So you can basically tell that using the last entry there, if it's given by something like this. And notice that I use small letters to denote the entries. Well, capital letter, I use it to denote a matrix. So what about the sum of matrices, or at least the difference of matrices? You can only add two matrices if they both contain the same amount of rows and columns. So nonetheless, you cannot add them. So that means like if you have an A2 by 3 matrix plus maybe like a 3 by 4 matrix, you cannot add them because like it doesn't make sense, because what you're going to do is like you add the corresponding entries. Let me just show you what I mean by adding the corresponding entries. Let's say I have matrix A given by 1, 2, 3, 4, and I have matrix B given by 0, 4, 5, 7, and then 7. Then let's say I want to find A plus B. So how do I find A plus B? You just add the corresponding entries. Row 1, column 1, add that with row 1, column 1. So we have 1 plus 0, that's just going to give us 1. Row 2, column 1, add that with row 2, column 1. So that's just going to be 4 plus 2 plus 4, which is just going to give us 6. And then row 1, column 2, add that with row 1, column 2. That's just going to give us 8. And then row 2, column 2, add that with row 2, column 2. That's just going to give us 11. So that's A plus B. And A plus B is the same as B plus A. Since it's just addition, the order doesn't really affect anything. And now, if we have like A minus B is the same process as that. You subtract the corresponding entries. A from B, deduct B from A, I mean. That's what I mean. So you have row 1, column 1. Remember, it's A minus B. It's technically A minus B. So you have 1, row 1, column 1, entry, subtract that from B. So 1 minus 0, that's just going to be 1. And then 2 minus 4, that's just going to be minus 2. And then 3 minus 5, that's just going to be minus 2. And then 4 minus 7, that's just going to be minus 3. So that's what you're going to have. So this is just going to be the same as minus into B minus A. That's just the same as that. So in a multiple choice question, if they give you A minus B, and then they ask you about B minus A, just know it's just gonna be, maybe let's say this one was 5, then you know that B minus A, that's just gonna give you minus 5. So that's just the same. So if you don't struggle when you approach multiple choice questions on this, you can basically play around with this. So what about when we take a scalar multiple of a matrix? I'm just going to give an example with the same matrix we have here. 2 by A, that's just going to be 2. And now remember, matrix A is the same as 1, 2, 3, 4. Just copy that there. So now we have something like this. What you're going to do is multiply every entry in here by this scalar multiple. So what I'm going to have is like I'm going to have 2. 2 by 1 is 2. 2 by 2, that's 4. 2 by 3, that's 6. And 2 by 4, that's 8. So that's what you're going to have. That's basically what you're going to have. When you have a scalar multiple of that, you're just going to distribute that inside. So just multiply every entry by that. The same applies like if you have like 4 multiplied by 8. That's just going to be the same as that. So you're just going to have 4 by 1, which is just going to give you 4, and then 4 by 2, that's going to give you 8, and the 4 by 3, that's going to give you 12, and 4 by 4 is the same as 16. So it's really not that complicated, really. So, point of view, you can only add matrices, add or subtract matrices if they contain the same amount of rows and columns. Nonetheless, you won't be able to add them. Okay, so now what about multiplying two matrices? And another thing I like to mention is that AB is not the same as BA on matrices. It's not the same. It's just not the same. That's why you have to be careful. And just because you have AB equals BC or CB or anything, this doesn't imply that C equals A or A equals C. It doesn't necessarily mean that. C can we have 1, 2, 3, 4, and then we have matrix B. Let's say 0, 1, 4, 5. It can be, you can basically play around with these numbers. So, or you can just write your own matrix and just follow the steps that I'm about to do. So if I have AB, what I'm gonna do is like I'm gonna take this number here, I'm gonna multiply that with this number. So I have 1 by 0. Now I add 3 multiplied by this one here. So it's just gonna be 3 by 1. And now for the second row, first column, you just basically repeat the same process again. So now you're just gonna have 2 multiplied by 0. So you have 2 multiplied by 0, and then plus 4 multiplied by 1. 4 multiplied by 1, and that will be the first columns of the first 2 rows. And then similarly, you can work on the other one. Now you're gonna have 1 multiplied by 4, 1 by 4 plus 3 multiplied by 5, 3 times 5. And now on the last column on the second row, well, you're gonna have 2 times 4, 2 by 4 plus 4 multiplied by 5, 4 by 5. So you can further simplify that. You're gonna have 1 by 0 is 0, and then 3 times 1 is 3. The sum of that will be 3. Similarly, you can get the sum of when these two products, the sum of these two products will be 4. So 1 by 4, that's 4. 3 by 5, that's 15. And 15 plus 4, that's 19. 2 by 4, that's 8. 4 by 5, that's 20. The sum of that will be 28. So notice something here. Notice that for the product of two matrices to exist, the number of rows from the number of columns from the first matrix must match the number of rows from the second matrix. So the columns of the first matrix must equal the columns of the second matrix. So let's say maybe we have an m by n matrix and a k by t matrix. For a by b to exist, that basically means like n must be equals to k. That's only when like AB will exist. And for BA to exist, that's only when like the T is equals to M. That's only when the two will exist. So the columns of the first matrix must be equal to the rows of the second matrix. That's only when the product will exist. So okay, so when we look at this example here, we have a 2 by 3 matrix here, and we have a 2 by 2 matrix here. Now, does AB exist? So let's see. Here we have 3 columns, but here we have 2 rows. So that means that this one is undefined. So we cannot find that. But now let's look at BA then. So this is the first matrix now, the order here. This tells you B is the first matrix here. So now B by A. So if we look at here, we have 2 columns. And if we look at here, we have 2 rows. So that implies like, yeah, the number of columns on the first matrix is the same as the rows for the second matrix. So this one will be defined. So how do we find that? Okay, so now we are looking for BA. So now I would say 1 multiplied by 1. It's just gonna be 1 by 1 plus, and then 2 multiplied by 2. Then we have 2 by 2. Then for the second row column 1, we'll have 3 multiplied by 1 plus 4 multiplied by 2. And then for the first row, second column, we'll have 1 multiplied by 3 plus 3 multiplied by, 2 multiplied by 4. And then for the second row, second column, we'll have 3 multiplied by 3 plus 4 multiplied by 4. And for the last row, first column, for the last column on the first row, we're gonna have 1 multiplied by 5. It's basically this one times this one, and this one times this one, and sum that. So we have 2 by 6, and we're gonna have 3 by 5 plus 4 by 6. And then from then it's just a matter of like simplifying that. 1 by 1 it's 1, 2 by 2 it's 4, sum that it's 5, 3 by 1 is 3, 4 by 2 it's 8, and 8 plus 3 it's just gonna be 11. And then Then we have 1 by 3, it's 3, 2 by 4, it's 8, 8 plus 3, that's 11, 3 by 3, it's 9, 16 here, we'll have 25, and then 1 by 5 plus 2 by 6, so we're going to have 12 plus 5, which is just going to give us 17, and 3 by 5 plus 4 by 6, 4 by 6, it's 24, 3 by 5, it's 15, then we're going to have 39, so that will be BA. So that's just how you find the product of two matrices. And now notice that since for this one and this one tells us that okay, let me just reverse that. We were calculating BA. Remember, this one was a 2 by 2 matrix, and A was a 2 by 3 matrix. Keep in mind that this one and this one tells us whether or not the matrix is defined. Well, this two will tell you the order of that matrix. Notice that it's 2 by 3. That's what we have here. BA is a 2 by 3 matrix. So that's another thing you should keep in mind. And another thing you should keep in mind is the identity matrix. So this is an identity for a 2 by 2 matrix. An identity for a 3 by 3 matrix will look something like this. Notice that diagonally, from top left going bottom right, you have ones, and the rest of them will be 0. That will be your identity matrix. So this one is for identity for a 2 by 2 matrix, and this is an identity for a 3 by 3 matrix. Similarly, you can do a 4 by 4 matrix. You just have ones diagonally, and the rest of them is just zeros. So that's another thing you should keep in mind. Okay, so now let's look at an example of that. Let's say we have matrix A given by this, and then we want to find matrix C such that either A plus 2C equals 2A for the first one, and then the product of A and C, the product of matrix A and C is the identity, and then the square of matrix A minus 2 the matrix C will give us A. And then we want to see how we can solve such problems. Okay, so now let's find matrix C such that A plus 2 times C will give us 2A. Well, given that A is given by this matrix then. So now for the first problem here, let's look at it. For number 1, A plus 2C is equals to 2A. So now when we look at this one here, we can simplify to 2C is equals to A. So that means that C is equals to half A. So that means we just distribute half inside matrix A. So we have half into 1, 2, 3, 4. Something like this. And when we solve this, we're going to have half 3 over 2, 1, and 2. So that will be the solution for number 1. And now number 2, let's keep this one. We're going to solve it last. So what about number 3? So when we look at number 3, we have A squared minus 2C is equals to A. So this will give us 2C equals A squared minus A, meaning that C will be equals to half A. If we factor by A, you're going to have A minus the identity. That's one way you can solve this. Basically, because A times the identity will just give us A, since the identity is a determinant equals to 1, so it doesn't really change anything here. So, okay. So what this means is we can say we have half, and A is given by 1, 2, 3, 4. Or you can just take this one since you already have half A. And then we have this multiplied by A 1, 2, 3, 4 minus the identity, which is just 1, 0, 0, 1, the identity of a 2 by 2 matrix. So we'll have something like that. And then half A is the same as 1 over 2, 1, 3 over 2, and 2. That's half A. And then here we're just going to subtract the corresponding entries. Then we have 1 minus 1, which is just going to give us 0. And then we have 2 minus 0, which is just going to give us 2. 3 minus 0 is 3. And then 4 minus 1, that's just going to be 3. Then we have something like this. And from then it's just a further multiplication of that. So we're going to have half times 0 plus 1 by 3. Then we have 3 over 2 by 0 plus 2 by 3. And then we have half times 2 plus 1 by 3. And then we have 3 over 2 by 2 plus 3. And here we're going to have 6. And here we're going to have half times 2, which is just 1. And here we're going to have 3. So 1 plus 3, that's just going to be 4. And then 3 over 2 times 2, that's just going to be 3. Then add that with 6, you're going to have 9. So you're going to have something like this. You're going to have something like this. Or you can just find A squared first, it doesn't matter. And then you subtract A from there. And then you just divide every entry by 2. Then what about AC equals I, given A is denoted by this 4 entries, then it's a 2 by 2 matrix. Now when you have this case here where you multiply one matrix by another and you get an identity, this just implies that C is the inverse of A. But I haven't talked about inverses yet. So how am I going to solve this? So we know that matrix A times C will give us an identity, and A is a 2 by 2 matrix. That means we're going to have a 2 by 2 identity, which is just denoted by this. And then A is given by 1, 2, 3, 4, and then we want to find matrix C. So let's just denote matrix C as A, B, C, D, something like this. And then we want to find that matrix. The reason I'm doing that is because I haven't showed like inverses yet. So what you're going to do is like multiply, then you're going to have A, 1 times A, that's A, plus 2 by C, 2C here, and then 3 by A, you're going to have 3A, and 4, then we're going to have 4C like this. And then we're going to proceed, then we're going to have 1 by B, it's just going to give us B, and then 2 by D, then we have 2D, and then 3 by B, we have 3B, and then 4 by D, that's just going to give us 4D. So we have this equals this. So you just equate the corresponding entries here. A plus 2C will give us 1, and 3A plus 4C will give us 0. So from here we can find A. A will be 1 minus 2C. Then we can plug that there. Then we have 3 minus 6C plus 4C equals 0. Then that means like 2C will be equals to 3. And then from then that means C equals 3 over 2. And then from then we can find A, because we're just going to basically plug C here. Then we're going to have minus 2 where we solve for A. And similarly you can repeat the whole process of finding B and D there. So we know that B plus 2D will correspond with 0 here. And then that means that B equals minus 2D. And then we have 3. That's just basically B, because you have 3B. I've just plugged minus 2D there. Plus 4D. Plus 4D will give us 1. And that means like we'll have minus 6D plus 4D, which is giving us minus 2D equals 1. And then from then D equals minus half. And then from then that means that B will be equals to 1. So that means that matrix C will be given by minus 2, 1, 3 over 2, and minus half. That will be matrix C for this problem. So now there's another way you can like solve this. Remember, if y equals f of x, then we know that x is equals to f inverse of y. Similarly, if we have a and its inverse, I mean its identity there, we can basically obtain something like this. Then we have a inverse of that. So that's when I'll be introducing like inverse. Remember, here you just obtain like notice the relationship of what you obtain here. So we can basically find the inverse by transforming a into its identity, and also the right side is going to be changing as well. And when we obtain the identity on the left, that means on the right will have an inverse. So that's when I'll be doing inverse matrices.